Welcome back. Today we continue our investigation into the mystery spikes of our usage of GitHub Runners in the Apache NuttX project. And we won't stop our investigation until we figure out what the heck happened in the period of January and February 2026. Why are we using so many GitHub Runners during that period of time? Today we look at one specific hypothesis. We shall verify and validate. NuttX apps, are they actually using too many GitHub runners? Or are the GitHub runners actually used by the NuttX repo, not by the NuttX Apps Repo? Well, today we'll find out. In our last video, we talked about running this job, NuttX GitHub jobs, that will export the GitHub jobs like this into a TSP file, a tab separated value file. And we took this file and imported into Google Sheet like this. Today we'll use this file to continue our analysis. Now we created two extra columns here that we highlighted in blue. The first column is for the name of the repo. So either NuttX or NuttX Apps. To figure out which repo we are using, we took the URL, which is this, and we extracted the repo name from the URL. The second column that we added is for the month. To get the month, we took the jobs that were started. We took the date of the job start date. Then we extracted the year as well as the month. And we get this. Now we have a whole list of jobs here that were executed by GitHub Runners for the past year of March 2025 to March 2026. And we added in the two extra columns here, one for the repo and one for the month. As I mentioned earlier in my previous video, this spreadsheet contains all the columns for all the GitHub jobs that were run during this past year, as well as the job duration. This is in milliseconds, followed by the PR that triggered the job. So this is a denormalized spreadsheet. One PR can trigger multiple build jobs. That's because one PR can be submitted to multiple commits. And when we have multiple commits, it will trigger off multiple CI build jobs. Right, so let's go ahead and verify our usage of GitHub Runners. Do we find more usage in the NuttX Apps Repo, or are they coming from the NuttX Repo? To answer that question, we take this spreadsheet and we create a pivot table like this. We drill down by the repo name, so we have NuttX and NuttX Apps. We split it up by month. Let me just zoom out a bit. So as I mentioned earlier, we have 1 year's worth of data from March 2025 to March 2026. And here's the data for the NuttX repo and the data for NuttX apps. Now, column C, count of job database ID. Every single GitHub job will get a unique database ID. This is the run ID or the job ID. So the number that we see here, this corresponds to the number of GitHub jobs that were triggered for that particular month. Next, we have the sum of run duration in milliseconds. This is the sum of the time that was used to run the GitHub jobs for that month. The unit is in milliseconds. So do you see this number here? It means that we have actually consumed 1,408 1,408,000 seconds of GitHub runner time. Now this number here is in elapsed time, not in the actual GitHub runner usage time. That's why we had to multiply by a magic number, 7.4, to convert this elapsed time into the actual runner time. We'll come back to this in a while. Now we have a chart here that shows how much time was spent per month on each of the jobs. This chart here follows the utilization chart quite closely. Here we plotted the GitHub runners by date from 1 year ago, January 2025 to March 2026. So we are trying to find out what happened during the months of December, January, and February 2026. These two peaks that we see here. Well, if we look at the charts here, we see a corresponding pattern. So, yep, we are spending more time during those last 3 months running GitHub jobs. Remember, this is the elapsed time for our GitHub jobs. We're spending more time in the NuttX Repo, and we're also spending more time in the NuttX Apps Repo. Right, so back to our original question. Are we spending too many GitHub runners on NuttX apps? Well, if you look at the data here, when we sum up the duration, we see that NuttX Repo takes up 84% of the elapsed runtime for our GitHub runners, whereas NuttX Apps takes up only 16% of our elapsed runtime for GitHub runners, which means that the vast majority of our GitHub runners are spent on the NuttX Repo, not NuttX Apps, which is quite interesting because we said that NuttX jobs for the NuttX Apps Repo will consume a lot more runtime than the NuttX Repo. I have a chart here that explains what's going on. Here. If you look at this chart that I explained in an earlier video, we have a step here that will look at the architecture and the board, whether it's from ARM, ARM64, RISC-V, and decide which platforms to build for that particular PR. Now, for NuttX PR, not NuttX Apps, we can selectively build for a specific architecture like ARM or ARM64. So if the architecture is only for ARM, we really have to build only for the ARM architecture. We don't have to worry about ARM64, RISC-V, and so on. But for the NuttX Apps Repo, all the NuttX apps will affect all architectures. Therefore, a simple PR for NuttX apps will force a rebuild of all the architectures. Now, which means that every single NuttX app PR will undergo a complete build, which will finish in 3.5 hours. Whereas a simple build of one architecture for the NuttX Repo could be as quick as 1 hour or 2 hours. Definitely a lot quicker than building a complete NuttX app PR. That's why I kind of expected the NuttX apps build time to be a lot higher than this 16%. Well, surprisingly, the numbers say that we are still spending a lot of time on the NuttX Repo, even though NuttX Apps PRs require more time to build. And the reason why is that just look at the sheer number of PRs. Well, we don't have the actual PR number here, but we can see that these are the number of builds that were triggered by NuttX Repo and number of builds for NuttX Apps Repo. The number for the NuttX Repo is just overwhelmingly huge compared to NuttX Apps, which explains why a huge chunk of the build time comes from the NuttX Repo. Now, this is the data from the past year, that's 12 months. What about the past 4 months? Maybe the pattern is different. So we took the pivot table and we did a filter for the last 4 months from December of 2025 to March of 2026. This is a partial month, of course. That's why the numbers are lower. We do the same thing for NuttX Apps. Surprisingly, the numbers are quite similar. We're spending 84% of the GitHub Runners on the NuttX Repo. Compare that with the whole year, 84%, the same. The pattern remains the same. There isn't any change between the last 12 months and the past year. But interesting thing is that if you look at the run duration, the sum of run duration, this is 17 million, and this is 34 million, which means we actually spent half of the GitHub Runner times on just the last 4 months, and March wasn't even a complete month. Same thing for the NuttX Apps Repo. We see that we consume over 3 million seconds of GitHub Runners for the build time. Compare that with NuttX Apps for the entire year, it's 6 million. Again, that's about half, which means that we actually spent an incredible amount of build time on the past 4 months alone, which might explain why we are seeing this pattern here. Imagine out of the whole year of GitHub Runners, we are spending half of the amount of time within the past 4 months. Why are we spending so much GitHub Runner hours during the past 4 months? Well, we have to look at our other hypotheses and validate them. So again, we have to figure out, are we really handling too many PRs? We have to now do a pivot table of a number of PRs by month to figure out if we are running indeed too many PRs in the last 4 months compared to the rest of the year, and whether there's some kind of limit that we're hitting. Also, we need to go into the PRs that are the most expensive, the most costly PRs to build. What exactly is taking up so much time for GitHub Runners? Are they having some problems that prevent them from building correctly in their own repo? Or maybe there are some technical problems that are causing this PRs to build again and again. So a couple other issues that we need to worry about. But today we have disproved the hypothesis. NuttX apps, even though they consume 3.5 hours to build per one single PR, and multiply that by the number of times they get resubmitted, NuttX Apps Repos don't actually take up that much time for the GitHub Runners. We see here that NuttX Apps only take up 16% of our GitHub build time, compared to 84% for the NuttX Repo. Therefore, we have disproved the hypothesis that NuttX apps are taking too many GitHub Runners. We have to go back and look at the other hypothesis to validate and verify them. Now, a bit about the run duration. We are looking at the duration of the job. This is the elapsed duration. This number here is in milliseconds. We got that by calling the GitHub API. Now, if we look at a typical build job in NuttX, let's take a long one, a 3-hour one like this, which is a complete build. This is a complete build that has got all the jobs. That's why it takes 3.5 hours. If we go into the usage, now notice that the elapsed time is 3.5 hours, but our jobs are running in parallel. When we add up the runtime for all the jobs, they will exceed 3.5 hours by a lot. We're looking at 1 day, 5 hours. This is equivalent to 29 hours. We are charged for 29 hours of GitHub Runner usage. But the problem is that when we call the GitHub API to extract this number here, we only get the elapsed time, 3.5 hours, not 29 hours. That's why in the earlier video, we talked about a magic number, 7.4. We multiply 3.5 hours by 7.4 in order to get this time here. And this is the time that matters, because this is the time that appears in our GitHub Actions policy, that we must not consume more than 25 full-time runners. When we see 4,200 hours, it refers to this time here. But we don't have this time. Therefore, the best thing we can do is that we take the elapsed time. The API will tell us that the elapsed time for this job is 3.5 hours. When we multiply this number by 3.5 hours, by our magic number, 7.4, we will get, hopefully, this approximate number, 29 hours. So we did some reverse engineering to figure out that the magic number is 7.4, because when we divided this number by 3.5, we get roughly 7.4. And this is how we try to comply with this requirement in our GitHub Actions policy. And this is how we get this number here. It's an estimate. We use a magic number 7.4, but the true experience, it actually matches our usage quite closely. Right, so that was a short explanation of our run duration in milliseconds. What's next? Well, we have to move on and validate the other hypothesis for our problem, our mystery here. Why are we consuming so many GitHub runners? We have to dive into specific PRs to understand what exactly is happening within a single PR. Why are we going through so many rebuilds? We also mentioned in a earlier video that we looked at the most expensive PRs. And we saw that the most expensive PR, this particular PR, took 85 hours of elapsed time. If you assume that one rebuild, full rebuild, takes about 3.5 hours, that's like 24 times of a full build, which means it's the equivalent of a developer resubmitting a PR 24 times and waiting for the job to complete 24 times, which is quite cruel, quite absurd. Next thing that we have to do is to dive in and figure out why did we consume 24 times the average elapsed duration for building this particular PR. Is there some technical issue that's causing this PR to be rebuilt again and again? Or is there some problem with the approval process that requires 24 times of resubmission and rebuild? So that's our plan. Moving ahead, we will zoom into a particular PR to understand further why we are taking so much time to handle some of these expensive PRs. So all the articles that I presented today and all the code and spreadsheet can be found in the video description below. We'll talk more in the next video. Thank you.